Okay, ladies and gentlemen, we're going to take a look at some transformations here. Now, this is for chapter 4 of your geometry, but it also applies across many of the topics that we go through in math. A transformation is where you take some image and you change it into something else. So, for example, if we have a light shining on somebody that is holding up the bunny ears with their fingers, and then you show the bunny ears up on the wall of the screen. What you have is you have a pre-image. The pre-image is this. It's the thing that makes the image, okay? So this is what creates the image, and the image itself is what is shown on the wall. Now, if we look down here in reflections, we have 1, 2, 3 various isometries. Iso meaning symmetric, okay, or matching. Metries meaning measurements. So we have matching measurements. Now, the first one is a reflection. So if I'm given this original figure with coordinates at 1, 1, 1, 5, 1, 1, 2, 3, 4, 5, 6, that's my pre-image. That's where I'm starting. Now, if I reflect that across the y-axis, I flip it over, I reflect across the y-axis, I now have an image. And that image is a, with a little apostrophe above it, A prime is what that's called. B prime, C prime, okay, A prime, B prime, C prime. And those, you can find the various coordinates for those, because if this was 1 this way, the other one's 1 this way, so I have -1, 1. This was 5, 1. This would be -5, 1. This one was 1, 6, would be -1, 6. And so we can find the coordinates of that reflection, flipping it this way. Now we could, of course, flip it the other way. We could even flip it over any other line you wish. So the key here is taking a pre-image and turning it into an image. So pre-image to image. Now, you also have a translation. A translation is where literally something simply moves from one place to the next. So we move from here to here. We simply moved it back. So instead of flipping it over, we're simply sliding it backwards. And so you come up with a translation. And again, the same thing can be had. And the distances, if this moves 1, 2, 3, 4, 5, 6 units this way, then this has to move 1, 2, 3, 4, 5, 6 units this way. And it moves over. Okay, so we would say this would be a 6 units left. 6 units left would be its translation. Now you also have a rotation where I take something that was like this and I rotate it and it turns like this. So where this was taller, now it's longer. And where it was skinny, it's not just as tall. So each of these can be figured out. And so we're rotating it around here. In this case, it's a 90-degree rotation. So that is the basics of transformations and isometries, and we're only dealing with ones that stay congruent, meaning they stay exactly the same shape and size. So if I have my shape right here, have this little shape, and I put him on my graph, I can find the coordinates of each of the corner points for this little shape. Now, using that, I can do a transformation, and I can slide it. I can even do multiple transformations. You'll notice it's still oriented the same way. The notch is still in the same direction. I can put it anywhere. That's going to be a transformation versus a reflection where I flip it over, or a reflection where I flip it over this way, a reflection where you flip it over. The key is you're flipping it. That's the deal. Now, you also can have rotations. So if I rotate this around, I can rotate it there. I can rotate it back. I can rotate it this way. I can even rotate it around some other point. I can even rotate it this way, but you'll notice it's always the same shape and always the same size. That's the key to an isometry, is always same shape and size. Now, by the way, there is one little thing. If I do a series of isometries, so for example, reflected over the y-axis and then reflected over the x-axis, that ends up being the exact same as if I simply rotated it 180 degrees around the origin. So we can come up with compositions of transformations. Those compositions could be slides with a rotate and a flip. So we come up with all those. So take a look at those as you approach this section.